motivation of this, I know some of you already noticed, those who have been with us for some time now. So the motivation for this crash course is really the next module, module 2, which will cover Lie groups, Lie algebras, and representation theory. So before this crash course, we did a crash course on topology and differential geometry. So you can have a sense, some understanding of basic understanding of manifolds. In this case, smooth manifolds, because Lie groups are not just groups in the thing. Don't just carry the algebraic structure of groups. They are also manifolds. So we had a crash course on that. So now we are doing a crash course on the group side of thing. So that's really the purpose of it, of this crash course. So in terms of the learning journey timeline, first of all, before I go through this, George, I'm still on, right?
Yes. Yes. Sorry.
Yeah, someone is saying the echo is okay. So the sound seems to be okay now. Yeah, sorry for that. This is the first time I'm using this. Yeah, okay. So David is also okay. So yeah, cool. Yeah. So in terms of the learning journey, there's one module that I didn't put here, when we covered finite dimensional Hilbert spaces stuff, that we call the foundation module stuff. So, but this is really what matters to us for where we want to go, which is here. So we've done this, I believe it was 9 sessions or something. And now we are here, this course, which will start next week, next Friday, around the same time. And I'm not sure yet how many sessions there will be, live sessions, at least 8. And it's possible that we will go to 12 lectures, maybe a little bit more, depending on your appetite for, how much you want to dive into, general abstract group theory, right? So I'll try to focus, obviously, on the key things that we need for this section. But nevertheless, there will be some stuff that will be very useful, even not just in the context of Lie groups and the algebra stuff. If you want to do other, other applied topics and these things, like cryptography, this type of stuff. So, but the focus will be mostly to take us here. So the approach that I will be taking, so we will start from very, very, very basics, just to give people the opportunity, to build up before we get into groups. So we'll start with the basic definition of binary operation on a set, for instance. So the only prerequisite you need is like essentially set theory. It will definitely help if you have some sort of exposure to university level mathematics, in particular linear algebra stuff. But if you don't, it's not the end of the world. There will be, you should be able to follow as long as you have the basic set theoretic stuff. But it really helps. And in fact, looking at the survey, by the way, let me just take the opportunity to pick up the survey. I don't know if the survey form that I've been sending to give me an indication of the level of abstraction. And I know that so far, most of those who have signed up for this to attend, to take this course, have been exposed to university level mathematics. In particular, there is a good chunk of survey takers who have said they have been exposed to group theory, which is good. So for those who are struggling, I assume that you should be able to Discord server, so you can ping someone there to see if you can get any extra help in these things if you are struggling. This is for those who don't have are not coming from haven't been exposed to university level math stuff. So here's a survey for those of you who haven't seen this before. I think I've shared this a few times on the chat on the Discord and also on the newsletter. So if you are here, please take this if you are planning to take this course, so I can have an idea who's attending and these things in terms of your background, in particular, whether you've been exposed to group theory, and also how comfortable you feel with abstraction and these things, just to make things easier. Okay, so going back to this, I'm still on, right? George.
Yeah, yes, I can. I'm having connectivity problems myself today, but I can still hear you. I lost my own video.
Okay. Yeah. Thank you.
Seems I can't run Crowdcast and the survey at the same time.
The UK being here, we are getting hammered. So guys.
I hear you.
Yeah, I am back. I disconnected the VPN also, just in case. Crowdcast is
All of these video conferencing things really push the research.
These are just examples. Obviously, you can do a Google search and these things to find out other applications of group theory in these fields. But this is just a highlight. In chemistry, crystallography, for instance. In cryptography, for example, this is the Diffie-Hellman key exchange protocol, for instance. This is that plays very important role in secure communication nowadays in the modern web. So in machine learning stuff, if you are interested in geometric deep learning, for instance, in fact, I will see if I can collect some interesting resources to send you next week before the session, just to some articles and these things where you see these things in action in machine learning and some of the other topics that I'm just highlighting here. In quantum computing, obviously, a lot of you, in this community, you are very interested in quantum computing, and you already heard about, quantum error correction stuff and these things. But, group theory also plays a very important thing in anything. in the machinery of quantum error correction. Error mitigation too. There are the thing where it's group theory is everywhere essentially. Group theory is really ubiquitous. The thing. So I hope you get some motivation to to learn this very interesting topic. And I will be sharing some resources around these applied topics for you to get even more the opportunity to see how powerful this subject is, and hopefully you will also see how beautiful it is. So bear with me on Monday. I will follow up with you with some resources. Now, some practical tips before we go. Let me just check the chat to see. Also, robotics. Yeah. So someone is highlighting some of the thing. Yeah, indeed.
I would mention a third one. Robotics overlaps with it, which would be graphics, video games, and even virtual reality.
Yeah. It is a ubiquitous topic, really, and you have the opportunity to build up. For those of you who are new to this, to start from very basics, and then go and build up your baseline knowledge on this topic. Yeah. Okay, so this is very interesting. So Bob Miller is saying I use group theory to design origami models. That's very interesting. Maybe one of the things that we can do, actually, especially the community members, maybe as we go through the group theory stuff, we could host some sessions with the thing on the applied side of things. For someone to give a guest talk, for instance, on how they are using group theory and these things, just to keep people motivated. For example, Bob could give a talk about what he's being how group theory is being useful to his work, not necessarily having to not necessarily share any proprietary stuff and these things, but just a high level talk just to keep people motivated. That will also be very valuable to the community. And I was actually also thinking about inviting on the cryptographic side of things, someone to have a guest lecturer on cryptography, just for people to see the group theory in action in cryptography. For example, I was mentioning about a use case in the key exchange, in this case, a Diffie-Hellman protocol, for instance. But yeah, definitely, maybe this is one of the things that we should do more often, is to have, as we build up as we become more sophisticated on the topic, as we have enough, we invite someone to come in and show how the concept that you have just learned is being deployed. So yeah, we will do that. Okay, so some practical tips. This is the same for those of you who who took the topology and the differential geometry crash course. This is the same advice, really. The first thing is embrace abstraction, or what I would like to say, take the abstraction red pill. By this I mean, I know it's a very challenging, especially for those of you coming from engineering, software engineering background, for instance. When you learn a new stack, normally you go through the developer documentation. You see some sample code and these things, and then you build up your thing from there. So examples are always the first thing in your head. So by this, I want to challenge you to do the other way around. When you see a mathematical definition, the thing, don't worry about the first thing that should come to your mind is not can I see an example? Try to see actually what can I do with these axioms that define this object. So this is the level of the thing that I would like you to try to embrace abstraction. So the first thing that comes to your mind is, what consequences, what constructions, what stuff can I get out of these definitions, as opposed to can I see an example? We will have examples, obviously. It's always good to see examples. But if you want to feel comfortable doing things in abstract, proving things and these things, that's one of the first things that you need to try to get your mindset to switch from wanting to see example before you understand, to trying trying to get something out of the definitions, out of the axioms that are put in front of you. And the second advice is that, you know, this is like it's a one step at a time approach, really. You know, because things are built on top of each other. This is one of the things that you know, I've taken this approach. Let me go back to the slides, you know, for you to see how things are layered on top of each other, and these things to make the stuff much more digestible for you in a way. But take the abstract concepts, you know, because things are built on top of each other. Take the concept, you know, one step at a time. And if you are struggling with one thing, you know, don't try to skim through to try to jump into the next into the thing that has been built on top of the stuff that you are struggling with, because it will most likely backfire at some point. So to view this for the software engineering guys, this is essentially similar to technical debt stuff. At some point it will hit you back. So try always to, you know, even as frustrated you might feel and these things, you know, try to get the stuff before you go to the next thing. And also try to build your own mathematical intuition of the abstract concept, right? I mean, group theory happen to be some of those things that you can actually, in some sense, you can already, you know, use some sort of, you know, physical intuition in some of the stuff. But that's also a little bit dangerous, because, you know, pure mathematics is pure mathematics. It's you know, it has nothing to do with the thing, with nature and these things. In a way, I'm now talking like you know, a pure formalist. So, you know, you don't, you know, the mathematical concept don't need to be, you know, kind of inspired from like you know, from nature and these things, you know. So by that I mean, you know, when you see a mathematical thing, you know, it's not, it's very often not, it makes no sense. Or, you know, don't try to say what's the physical thing around, you know, what's the intuition, like a physical intuition or whatever you call it, around that concept, because it's just, this is just abstraction. It's an abstract concept. So try to build your intuition, but don't rely too much on the thing, on the thing. This is pure mathematics. The other thing I would like to advise is that try to do proofs, you know, by yourself. Practice doing proofs, you know, especially those of you, you know, who are interested in applied things like, for example, quantum error correction stuff and these things, you know. Because if you come up with a code with something, you know, error correcting code, you need to prove that, you know, the thing, you are expected to know how to prove things, you know, that the thing works, right? And these things, you know. So you need to learn, you know, doing proofs and these type of things, okay? And try to do it by yourself before you check other people's solutions. And very often, the way you prove something, you know, it's not, you know, it's, you know, it might be different from whatever the reference that you are using. That's fine, you know, because you might get there, your reasoning might be different from, you know, someone else, as long as, you know, the reasoning is okay, you know, as long as you get to the result, that's what matters, you know. But try to share it. This is why I really encourage peer-to-peer, you know, peer-to-peer study sessions, you know, where you kind of correct each other, you know, show each other what you know, what we are doing. So I will be challenging a lot in terms of proof. I will be giving you a lot of challenges in that respect, just to help you feel comfortable doing proofs. One thing also I would like to say is that if you struggle, this is, you know, if you struggle to understand a concept, you know, whether from me or, you know, from even the reference stuff that you will come across, you know, try to use different sources. You know, it might not be, you know, yourself who have the problem. Maybe the way that I explain it, or someone else or the reference has it explained, that's not clicking in your mind. Maybe another reference will, you know, do the job for you. You know, so try, if you're struggling with to understand something, you know, from the stuff that we go through, you know, try to cross-reference and see if you can get it through other sources. in a sense, I already said this thing of trying to set up a study group. I really recommend this. I know George has been very, very, very kind to provide, the weekly study sessions and these things. I really encourage you, especially I know that, we are like distributed, the community is coming from, spans different time zones. So try to set up a study group with someone closer to your time zone, because it's really important. This is where the peer-to-peer stuff, this is where you have the, the opportunity to, show someone else your proof and these things, for those of you coming from, programming background, is essentially the same thing. When you are like, doing peer review with another programmer, you show their thing, you get useful feedback. The same here, So I really encourage you to set up a study group so you can help each other.
And if you don't have a peer group, find a rubber duck or a puppy or a kitten to explain it to.
Yeah, that's definitely anything that any hack you can find to help you, get these things in your mind, that will definitely do. And the final quote, this quote here, mathematicians are like French. Obviously, there are a lot of very interesting, very important French mathematicians. But nevertheless, I like this quote. It says, whatever you say to them, they translate it into their own language, and it becomes completely, entirely different. So this is so much true, in particular in group theory. The concept of symmetry and these things. Symmetry of an object, these things. These are all like intuitive stuff that if you take an object and start to rotating it and playing around with it, but then translate it into the formal language of group theory, it becomes completely different. So you will see what we mean as we go through the axioms of group theory. Yeah. So that's one of the things that you need to think. Don't feel frustrated. There are. It's just formality stuff. Mathematics is a formal language. Okay, David is suggesting okay, or to your partner, wife. Yeah. So that's it. As you can see, I went through very fast because of the connection issues that we are having. And one thing I want to share before I open up questions and answer is, there is a GitHub repository where the slides will be available. I think I've already created the thing for the group theory section. If not, I will probably do it by Monday. The YouTube, there's also a YouTube playlist for the group theory crash course. So everything related to the crash course will be the videos, and this Q&A stuff and other stuff will be uploaded there. So just go to youtube.com and then put slash Zyko group. You will see the other playlist, but also the group theory playlist. And I encourage you to join Discord, please. Join Discord. This is especially for those of you on the survey saying that you haven't been exposed to university level mathematics. This is an opportunity to go there, introduce yourself. Don't feel shy or to introduce yourself. Just tell yourself the situation where you are at, and then someone will. I'm pretty sure the community, someone will ping you, and maybe you can have someone to mentor you, to help you with something. And to the rest, it's the place that you can set up study session, organize yourselves about setting up your group sessions and these things. It doesn't need to be through Discord. You can set it up outside. Maybe you can use Google Hangout or Google Meet or something, or Zoom outside. But it's just a way of having one place where you can come together and organize a study session. Yeah, so that's it really. The rest is like the trivial stuff. Feel free, please feel free to follow us on social media to get the latest updates and these things. Not just to do with this, because we are actually planning several initiatives on this thing. in particular, like integrated courses that I will be announcing over the coming weeks. So we are getting to a stage where we want to have a little bit more of an integrated type of courses as opposed to just mathematics. So by that, I mean we will have, for example, something on quantum computing that would have, the mathematics integrated, and then we have the quantum computing aspect of it. The same with cryptography, for instance. This is something upcoming. We'll have, a mathematical module, and then have the cryptography side of things. Topological data analysis also. We'll have like algebraic topology. We'll have the topological data analysis, the applied side of things. Yeah, and this actually brings me to something very interesting that I will be sharing over the coming weeks. So it's getting to a point where I'm not able myself, because of my commitment to the company, to be doing all these the stuff. Obviously, I love being being with you and these things, and I will always be present in these initiatives and these things. But I'm actually recruiting at the moment, graduate and postdocs to come and assist, deliver some of the sessions and these things that we are planning to do, because I cannot do them in parallel and these things, and also because of my limitations, in terms of commitments with the company. So yeah, so expect us to make an announcement, introducing the people who will be coming in, and yeah, I really look forward to providing more content, more courses and these things to the community, and the people that I will be bringing in, the others, I'm pretty sure that they will do well. And in fact, I will design the curriculum with them. So, the approach and these things will be, and in fact, some of them might be watching this later. So just a quick heads up. Okay, so now that's all I have to share about this. I wasn't planning to do this Q&A. I just decided to, okay, yeah, we'll do it just in the thing. If you look at the bottom bar, you should have something saying ask a question or something. So if anybody has any questions, please feel free to ask, or you can just put them on the chat also. It's fine. George, first of all, do you have any comments, by the way, George?
No, I think it's I like your approach. I'm not sure about swallowing the red pill, maybe nibble on it a little. But that's just me. I think that's a general problem that I have, is I try to do too much, so your measured approach is good. And to use another metaphor, don't try to drink straight from the fire hydrant or the waterfall.
That's right. Any other comment, please, guys? Anything? Don't feel shy. Ask anything you want. I would actually just while people are thinking about what to ask, I know we are like almost 40 minutes into the session, so I won't take the thing. I would like to know the thing from those who are online now, to see your background, not the usual, like the thing. I know you because you've been around, but I think we have new people. Like, for example, David. I'm not sure if I remember David. Okay, so Stefano is asking, will I also touch rings? Probably not. So we'll stick with just groups on this, but on the cryptography course, the integrated course that we are currently planning, we will definitely touch rings, yes.
And wouldn't you need some rings for the Lie theory?
That's also, yeah, on the thing we will attend, not on this crash course.
Yeah.
In the Lie theory section, yes, because we'll cover the notion of algebras and these type of things, so it helps to understand.
I'm hearing somebody's background noise they're picking up.
Okay. Would that be my background?
I don't know if that's you or who. I don't see where it's coming from.
Okay. Is that like TV or something?
Yes.
Okay. Does anyone has any other question? Okay, so David is introducing himself. Thank you, David. An engineer, worked on Amazon. Yeah, Astro, familiar with the basic quantum, strong background in here. Yeah. Okay. Good. Yeah, you definitely you are in a good position to take this course on group theory, really, and then go on to think to the Lie theory things, which will become very, 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 very interesting. Okay, that's interesting. Yeah.
Very cool stuff, David.
Yeah. Yeah, so he's saying I didn't get how topology was related to practical QM. Well, in a thing, Lie is what connects the two, brings topology into play, because Lie groups are manifolds, right? They are topological manifolds, or smooth manifolds.
Even in robotics, there's just the rotations. There are actually topological problems. I don't know if you've encountered something called gimbal lock or gimbal lock, where if you have a bad model of your rotations, things can get screwed up.
Yeah, so as you can see, there's a lot of yeah, so David is saying there's a lot of people like everywhere. Yes. Yeah, so it's really the application of it is really this is vast. The thing, this is one of the things that some of the graduates, the postdocs that I have in mind to come in to do some of the courses, we are trying to get them to jump into industry and these things. They were very amazed, because they are obviously pure mathematicians. They were very amazed about some of the applications that some of their research, actually, some of the stuff that they know is being used outside. So interacting with you is also a way of them, getting to see how industry actually is. How mathematics, plays a very important role in advancing some of the things of the industry. So someone is putting on the chat, we want to most likely rotate given sensor. Yeah. Yeah. Do you have any other comment, George? Overall, the structure of the thing of the program.
I like it. I like that it's focused on drilling down towards the matrix groups. That there are many side tracks one can get involved in that maybe it's good that we don't.
Yeah. Yeah, because at the end of the day, this crash course, the purpose is really on the Lie stuff, and these guys are the thing, the useful, the prototypes of what we
Yeah, I mean, like
in practice. Yeah,
I myself am interested in non-associative structures, but that doesn't really come into play here.
It might actually on the thing on the other stuff that we have planned. And something also I want to say, I know Stefano likes category theory. We will definitely have, this is one of the things that, that's why I'm very keen to hiring these, getting these grads and postdocs to come in. There's one actually doing, type theory, homotopy type theory stuff, So we will be having, that's the thing, we are now scaling this community, this mathematics community, online stuff building. So I'm really excited about some of the stuff that I will be announcing over the coming weeks once we have it in place and have some sort of a timeline put together. I see more on the chat. Yeah. And also another thing, I will be following up. I'm sorry to those who, for the career, for those of you in the thing, I will follow up with you as soon as possible. I was planning to do a presentation for those of you about the career stuff in our company stuff, but I couldn't do it on anything last month. Yeah. So for those of you who have the thing about the career stuff, I'll follow up with you. Yeah. So nobody has any questions. So I assume everything is clear, and these things, I mean, most of you already know how we do things here. So, it's more or less the same thing, for those who want the certificate and these things, and the same is the same approach again. So yeah, I assume that's why, there's no any other question. David, do you have any question? Because David is the only new person that I can see online right now. Those who are going to watch on YouTube, please, feel free to ping me on Discord. Yeah. So David is saying, I got lost early in the topology course. This one should be easier for me. Okay. Yeah. I mean, on the topology section of the thing, if you can hack yourself to understand what, a smooth manifold is, that's the thing, because Lie groups, the smooth structure will play a very important role in some of the stuff that we will go through and the thing. So yeah, okay, so you understand. Yeah, that's fine then. Yeah, the interplay between the group structure and the manifold, that's something that will come in the thing in the actual module. And it's actually very interesting that the initial topology was too general. Yeah, that's the thing. It's point set topology is we started from the very basics, obviously, because to a lot of people this was the first time that they are being exposed to this. And if we have just gone through finding a way of defining a manifold, it would be just so that's one of it would be just I felt it was going to be a little bit incomplete in a way. So that's why we started from baseline, starting from abstract point set topology, and then build our intuition through build our intuition also
rotations are the simplest example of where the global structure is different than the local structure, in that even in a circle, you can come back to where you were after going 360 degrees. That's a simple example of a global topological property, which is different from a real number where you can just keep adding and adding and adding and there's no end. That's a topological distinction.
Yeah, what I recommend you, David, he's saying definition was too general. I would easier for me to go the other way around. This is very interesting. From manifold to the thing. Okay, so what's your take on this, George?
Actually, I like that. That's the maybe.
So instead of starting from the topological thing, get from the manifold and then go down to the thing.
Yeah, and think of non-Hausdorff topologies, like discrete topologies, as being like non-Euclidean geometry. Just yeah, that's the way I've been tackling the abstraction. That if same as with we start with ordinary geometry that we're used to, and then say, wait a minute, what if? I think that to me, that's the abstraction thing, is asking what if. Well, what if we don't need this axiom? What if we generalize?
Yeah, he's actually saying something very interesting. He's saying the initial definition of topology made no sense. Yeah, I can imagine. It's very abstract. In fact, on the session, that's one of the reasons I say at the first sight, the axioms for topology, you might say, what's this has to do with the thing? But obviously, as we go through, through the metric topology, things start to become more things start to make more sense. Yeah. So.
So yeah, I have to think about that. I like the idea of starting with the more concrete and working back, because
the abstract,
the axioms didn't come from nowhere. They came from specific
obviously
problems.
Years of yeah, that's true. Yeah, that's very interesting. I'm trying to think. Obviously, coming from a mathematics background, this is how things are done. You always start from abstract, and then this is how.
Yeah, I had the same problem with my first group theory course. That was totally abstract. It was only when I connected it with group actions, the group doing something, that I had the aha moment.
Yeah, let me actually bring David. David, you want to come on stage just to share a thing, let's invite. Yeah, it's fine if you cannot join in this thing. It's very interesting. So David, share a bit of your thing about struggling with the point set topology.
I did. Good. Yeah. Oh no. There's an echo now. What do I do?
Yeah. Maybe.
Yeah, that's bad.
You have another window open or something.
Okay, now there should be no echo, but I turned my speakers off.
Yeah.
Let me get headphones. That'll work probably.
Yeah. Okay.
Maybe.
I mean, this is just extra stuff for those of you who want to leave now. That's fine.
There's only
the thing. I was just. Yeah.
Yes, I guess I can talk, but I can't hear you because I've got my sound turned off. That's not going to work.
Okay. Either. Yeah. Just so you can't hear us.
Okay. Now am I echoing? Now echo again. Yeah. Okay. I'll be right back with headphones. That'll work.
Okay. No worries, David.
Yeah, there's a little bit of discussion about the history of abstraction in the chat.
Yeah. Funnily enough, I think I don't. It's always like I seem to have some sort of latency in getting what people are talking on the chat.
I mean,
even though I'm the presenter,
I have a.
Where to plug them in? Is this working?
We still hear the echo.
One more. How about this one? Headphones, yes. Nope.
Yeah.
Crap.
Bob saying learn to count first, then number theory.
Oh, there we go.